Am I audible?
Yeah.
Okay. A warm and wonderful good evening to our esteemed guests, faculty, and fellow students. I am Srijita Mondol, a second year undergraduate student from the Department of Geology at Dugapur Government College and a member of the Geoscience Society. It was with profound pleasure and immense excitement that I welcome each and every one of you to this landmark session. Our speaker for the day is Mr. Amit Saw, a geologist from ONGC. He is here to impart his invaluable insights and compelling experiences, a session we have all anticipated with great eagerness and enthusiasm. The Geoscience Society was conceptualized back in 2023, beginning simply as a small WhatsApp group. Our initial vision was to forge a common platform that would unite geology students from diverse colleges across West Bengal. Our community, though perhaps young in years, is fiercely united by a singular profound passion: the earth, its dynamic processes, and the intricate science that governs it. We took a significant step forward earlier this year, strategically expanding our digital footprint onto LinkedIn and Facebook. This outreach has allowed us to connect with a wider constellation of geology enthusiasts, transforming our network into a larger, more vibrant, and highly interactive forum. The moment we have all been waiting for is finally here. Without further ado or delay, it is my privilege to hand over the proceedings to today's capable host, Divya Das, who will seamlessly continue the session and guide the conversation forward with Mr. Amit Shaw. Thank you.
Thank you, Srijita. A very good evening to one and all present here today. I am Divyashri Das from Presidency University and a member of the Geoscience Society, and I am delighted to be your host for this evening. We are here with the third talk show of our society, and by the end of today's session, we'll be making a hat trick in presenting talk shows. It's a mini milestone that we've reached, and these little milestones will help us move forward and take the society to greater heights. I extend my gratitude to the previous speakers, the audience, and all those who worked hard behind the scenes to make this event successful. Today, we have among us Mr. Amit Saw, who has completed his master's degree in applied geology from IIT ISM Dhanbad and is presently working as a geologist at ONGC. Mr. Saw will present a talk on oil and gas exploration and development, how we discovered resources hidden deep underground. Please keep your questions in the chat box. We'll take them up at the end. So, without any further delay, let's welcome Mr. Saw.
Thank you, Divyasri. Hope I am audible.
Yes, sir.
Yeah. So, good evening, everyone. Let's start the session without any delay. So, the topic is oil and gas exploration and development, and how we discover the Earth's resources that are hidden deep underground. So, this is the outline of the presentation that I will be presenting today. So, firstly, we will have a brief introduction about oil and gas, and then we will see the importance of oil and gas in the energy supply. And what is the future of fossil fuels, coal, petroleum, and gas in this net zero era? And are fossil fuel really replaceable by renewable energy? And this are like geopolitics and all. So after that, we will go into technical discussions like how fossil fuels are formed, the exploration cycle, and subsurface exploration technique, and then we will move into development cycle. That is the last stage of a field development. The audio is okay now. It's like the volume is okay now, the amplitude and all.
Yes, sir, absolutely.
Okay, thank you. So let's start. So this is the first slide, and you guys can see it is written like oil and gas contributes 50% of the global energy needs. So you can imagine how important oil and gas is for us. And then how do we find it? Like they occur very deep underground. They range from 800 meters to about 4,000 meters also deep underground. So we need to drill about 4 kilometer of length, 4 kilometer of section in the earth to get the oil. So if talking about Assam and Assam Arakan Basin, right now I'm working in Assam and Assam Arakan Basin. So in this basin, the usual depth of the well is 3 kilometers. So you can imagine the extent to which we go to extract the oil. And now coming to the cost that is incurred in drilling the well, it is around 20 to 30 crores for a single development well that is drilled in onshore, that is on the land, and the cost is significantly higher if we go to offshore wells. So this is the hardship that we incur to get the oil and gas. So this is also a reminder for all of us to use the resources judiciously. Moving on to the next slide. If you guys have any question at the end of the slide, you can ask it before moving me to the next slide. Okay, and this is the next slide. This slide shows the importance of fossil fuels only, like what percentage of energy does fossil fuel contributes. So you can see in this graph, this blue thing, this blue thing is oil, the contribution of oil, and this is gas. Let me take a pointer. Yeah, this is gas. So gas and oil are combinedly contributing around 49%, even in 2050. Right now we are here, 2025, and the graph shows an increasing trend till 2025, and the projection is that it will go down a bit. Like here also we can see the overall energy need is also stagnating. Okay, but like up to 2025 there's an increasing trend only, and here you can see a dip around 2020 and 2019. Can anybody from the session tell me what this dip is about? Why there is a decrease in energy requirement in this particular year? Let's make this session a bit interactive. Anybody from the session? You guys can text also.
Sir, can you repeat again the question, please?
Okay, so the question is there is a dip, there is a decrease in energy requirement in this particular year, 2020. You can see the graph is going down. The graph of oil is also going down. The graph of gas is also going down. So energy
Sir,
requirement is
lockdown.
overall. Yeah.
Sir, because of lockdown, there is no extraction take place, sir. Maybe.
Oh, good answer. So it is basically due to the coronavirus event, coronavirus pandemic. So at that time, the oil prices fell below zero also. Like the prices were negative. So the prices are negative. Let me explain why we are saying that the prices are negative. Uh, so for example, this is India, and this is some OPEC country. OPEC country, like Organization of Petroleum Exporting Countries. This is some OPEC country from which we are bringing crude to India. Okay, so this is going through a sea route. Let us suppose this going through a sea route. Okay, so the prices fall, like the demand was zero, like transportation decreased and export decreased, everything decreased. So the demand decreased significantly. So there was no demand. But why the price was negative? The crude oil price went below zero because the containers in which that contain the crude oil, okay, they were not being demanded by any of the countries. India is not demanding the container. Australia is not demanding the container. Nobody is demanding these containers. So the price of transportation is increasing continuously. Let us say the price of crude is 60 unit, and the cost of transportation is 5 unit. But this container is not being demanded by any of the country, so the price is going up. Price of transportation is going up because this stays here for so long, like 2 years or so. So price goes up, and it crosses the price of the crude. So that's why the price is negative. So this dip was due to the pandemic only. And now let us move forward. Okay, so we saw the contribution of oil and gas. Oil and gas contributes around 50% of the global needs. And then let us come to the other sources. The other major source is this one, electricity. Electricity contributes around how much? It contributes around 38% of the global energy needs. Also, this electricity is coming from what sources? Like this graph explains it. The graph on the right hand side, this graph explains where the electricity comes from. Okay, so we will come to the electricity a bit later. We will ponder a bit more on this graph. So let us see from 2020 to 2050, the contribution of gas is remaining the same. See the thickness. The thickness is the contribution. The thickness is remaining the same. That is the percentage is remaining the same. But like this much is 49%. This much this must be contributing. Let us say 20% or 30%. This 30%. So 30% is constant, but the energy need of us is increasing. For example, right now, right now our energy need is 100. Let me take a pen. Right now the energy need is 100 joule. And so oil and gas must be contributing 50% of the energy need. That is, oil and gas are contributing 50 joule. But in 2050, the energy need will not remain the same. The per capita energy need will increase. That is, the per capita means like per human being, the energy needed will be increased. So let us say in 2050, the energy needed is 200 joules. So again, the gas will be contributing, gas and oil combinedly will be contributing 50% only. So the 50% of 200 is what? 100 joule. So effectively, oil and gas contribution is increasing in absolute terms, but in percentage terms, it is remaining constant. So this shows the importance only that oil and gas is going to remain significant for a long decades, for many decades. Now coming to this graph, this electricity production graph. So this graph shows how much electricity is contributed by which sources. You can see coal. Coal is the major contributor of electricity. Like you guys must be knowing the name of NTPC, National Thermal Power Corporation. It is a major electricity producer in India, and the highest percentage of electricity, the highest contribution of source from which NTPC is generating electricity is coal. And we can see in the graph also, coal is the major contributor for electricity generation, and then gas. Oil is a bit less, very less, then nuclear, then hydropower, wind, and the least is bioenergy. The least is bioenergy. Hydropower significantly contributes to electricity generation, not in India, but in other countries. Hydropower is a significant contributor. But still, coal and gas are major contributors. Moving on, now we will focus on the geology part of the things. So we will discuss how fossil fuels are formed. So you guys can refer to books like the geologist students. There is a book by Tissot, Petroleum Geology by Tissot, and there is a book by Selly also, Petroleum Geology by Selly. So you guys can refer these books for the theory part, how petroleums are formed, and how migration takes place, what a source rock, what a reservoir rock. So for this basic reservoir related thing and geology related thing, you guys can read these books. These books are very good. So we will briefly see the things how fossil fuels are formed. The foremost important thing for the formation of fossil fuel is preservation. If you are not preserving the organism, it will decay and nothing will be formed. So you can see the cycle. We have plants, we have plants. Plants are eaten by animals. Okay. And then annual animal animal dies, and then it is decayed by bacteria, and then H2O and CO2 are released. Okay, and then this H2O and CO2 are again consumed by plants, and this cycle continues like this only. In general terms, this cycle continues like this only, and this rarely happens. This rapid burial and preservation thing rarely happens, once in a while. Okay, so this process is needed for preservation of the dead organism and the preservation. And after preservation, it revolves into oil and gas. So this is the necessary step. We will see few example how organisms, marine organisms or terrestrial organisms are preserved for the fossil fuel to be formed. Okay, so one example of rapid burial is, तुम्हें कोई चीज को अगर जल्दी से धरती के अंदर दबा देना है, तो what you need is, for example, you can talk about landslide. Landslide is an excellent way for rapid burial. For example, here is a pond and you have a mountain here. Okay. And in this pond, you have marine organism. Let us say lacustrine organism. Okay. Fishes and all. So let us say a landslide occurs. Landslide occurs. All the earthy materials goes in the pond. All the organisms that were present in the pond gets buried. So what happens due to this rapid burial? There is no chance of oxygen penetration. For preservation, what you need to exclude hydrogen and oxygen from the scene. If you remove these two things from the scene, the organism will be preserved. And this is why rapid burial is needed. When you do a when a landslide occurs, so there is no percolation of water. There is no percolation of oxygen. The oxygen that was initially present in the water will ultimately get out and will ultimately evaporate, and there will be no oxygen. And in no oxygen condition, that is anoxic condition, there will be no decay. There will be no bacterial decay of the marine organisms, or say the organisms simply, and they will be preserved. And after preservation, they will evolve into oil and gas. So this is the only thing. You need to exclude hydrogen and oxygen from the scene for the organism to get preserved. Any doubts? Okay, if not, then let's move forward. Okay, so let
No,
us
sir,
say
there are
ki,
no questions.
yeah, okay, great. Please let me know if there is any question in the chats also. Okay, now let's move to the next part. For example, let us say the petroleum is formed, then it will migrate and accumulate. We will deal this in the later part of the presentation also. Yeah, firstly, we will see these things. How organisms are preserved. Like there are four conditions. I have picked it from a book. Okay, we will discuss it one by one. So this is the first process: thermally induced stratification in a lake. Okay, so what happens? Suppose this is a lake. This is the lake, and the salinity of the water in this lake is 3.5 GPL. GPL is gram per liter. Okay, so let us say evaporation is taking place. So when evaporation will take place, the upper part, the upper water molecules, the water molecules that are present that are present close to the surface will evaporate initially. And due to this evaporation, what will happen? The density of this particular layer will increase. Done? So due to this, what will happen? There will be zonation of this lake. Like the whole water was initially 3.5, so this will remain 3.5 because no water molecule has escaped from this place. But water molecules have escaped from this place, though. So the density has increased, or say the salinity is increased. Salinity is what? Gram per liter. That is how much gram of salt is present per liter of water. So in this particular scene, salt has increased. Concentration of salt has increased. So let us say this has gone up to 3.7. Okay. Again, water close to the surface will evaporate. So let us say another layer is developed here. this becomes 3.8 GPL. So saline, so the water layers in the lake has been divided into different layers of different salinity. 3.5, then 3.7 and 3.8. And due to this stratification, what happens is circulation stops. Initially, if this is the lake, water circulates. Water circulates. Why? Water circulates due to what? Due to many reasons. For example, due to convection. Convection, you heat the surface water. The heated water goes up, so the cold water comes up. So, due to convection, water circulates. Due to flow of wind, the water circulates. But due to this stratification, what happens is circulation stops. And and when the circulation stops, what happens is the marine organism what was present here, ऑक्सीजन कहाँ से मिल रहा है ये पानी को? Oxygen is derived from this air, and this water has no contact from the air. Why? It is not being circulated. Only the top layer, only the top surface is exposed to the air. So this layer is continuously getting oxygen. The dissolved oxygen in the water is used by the organism, and when the dissolved oxygen gets depleted, it dissolves oxygen from the air. So oxygen in this layer is maintained. Done. But for this layer, it is not being circulated as of now. So what happens is the dissolved oxygen ultimately get consumed by the marine organism, and a time comes when there is no oxygen left in this deeper layer. So this deeper layer becomes anoxic. This deeper layer becomes anoxic. And when this deeper layer becomes anoxic, all the organisms that were present in this layer dies. Okay. And since there is no oxygen in this particular layer, the organism gets preserved. And once something is preserved, it will ultimately evolve into oil and gas. Done. Moving on to the next slide. If you guys have any question regarding this, ask me. Now, this is due to a condition of bad ocean stratification due to salinity contrast only. For example, let us discuss it. This is the main ocean. This is the ocean, and this is a lake. This is a small lake, and this figure shows the lake. Okay. So during high tide condition, let us say the water level is still this only, and here the water level is still this. During high tide condition, what will happen? The water from the ocean will go up and cross here and will get accumulated in this lake. So initially, the water, let us say the salinity of water in the ocean is 3.5. So initially, the water that will get accumulated in the lake will be 3.5. 3.5. Then this water will be evaporated. This water will be evaporated. तुरंत तो दोबारा हाई टाइड आने में समय लगेगा. हाई टाइड हैज अ पीरियड, तो दोबारा तो हाई टाइड आने में समय लगेगा. till that time, the salinity of this water accumulated in this lake will increase. It was initially 3.5, but due to evaporation, this will increase to, let us say, 3.6. This has increased to 3.6. Now again a high tide occurs. Again water goes from this ocean to this lake. So again there will be a water of 3.5 density. So a question might come to your mind, guys, that why the salinity of the ocean is not increasing? Because the volume is very less. Volume of ocean is very less, so the evaporation is not that significant to increase the salinity of the ocean. So again 3.5 will be deposited. Again it will get evaporated, and its salinity will increase up to, let us say, 3.55. Again in a high tide scenario, water will get from here to here and water will accumulate here, 3.5. So you can see there is a stratification. The layers have been stratified, and when the layers are stratified, there will be no intercirculation between the layers. And then when there is no circulation, the oxygen of the layer will ultimately get depleted and the marine organism will die. And once the marine organism will die, they will get preserved, and will evolve into oil and gas. So this is an example, classic example of stratification due to salinity contrast. Now let us see this example: continental shelf with upwelling. Upwelling means like nutrient. You guys uh, go to Sally book and search about nutrient cycle. So there is a nutrient cycle. matlab there are oceanic flows that circulates the nutrients in the ocean. Nutrients means the things to eat. It can be plant or it can be other organism also. Like they flow with the flow of water now. So this is an anoxic layer. Let me get a picture of it. Yes, this is a graph on the right hand side. Guys can see the presentation. The presentation is visible to you guys. Give me a check. Like presentation is not visible. Okay.
No, sir.
Now
Yes, sir.
Yes, sir.
great, thank you. So yeah, this is a graph showing the variation of oxygen with depth. This is water depth. It is increasing 1, 2, 3, 4 kilometers, and this is the concentration of oxygen. So at the surface, the concentration is the maximum. The concentration is this much, like 3.5 milliliter per liter. Okay. And as you go down, the concentration of oxygen goes down like this. And after a few meters, like around 800 meters, the oxygen concentration again increases, and then oxygen concentration becomes constant. In this particular part, oxygen concentration is constant. And here there is a sharp decrease in oxygen content. And the sharp decrease is due to what? Due to the presence of organism. यहाँ पे sharp decrease है मतलब यहाँ पे organism बहुत ज़्यादा है. Okay. Organism ज़्यादा होने से oxygen कैसे कम होगा? Because organism respire, they do respiration, and in the process of respiration they use oxygen, and as a result of which the oxygen is very low, like it is close to anoxic condition. So let us suppose this is an anoxic layer at a particular depth of 800 meters, and it is close to a continental shelf. So how the organism will get preserved in this anoxic layers? Let us suppose this organic anoxic layer is existing, and due to some upwelling, nutrients come from some place and 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 accumulates here by any chance. This is a very rare phenomenon, and this is how we get petroleum in shelf areas. If it would have been common, we would have been having very high amount of petroleums. So let us suppose a nutrient wave come and get deposited here. And in any case, if this get deposited here, they will be preserved because this is an anoxic layer. They are lying on a self area. They are lying on a self area, and this whole area is anoxic. So whatever marine organism will come with the flow of the wave, they will get preserved. And once they are preserved, they will ultimately evolve into oil and gas. So this is the funda here. There is an anoxic layer in every ocean at a particular depth. The depth may vary, and this is the anoxic layer. This graph shows the anoxic layer. Moving on to the next slide, and this is an ocean basin anoxic event. I have written the theory. Okay, the slide is not moving. Just a second. I will rejoin. Okay, I will be sharing my presentation. So anoxic events are like any event that makes the ocean anoxic. Hey, somebody, please allow me from the lobby. Yeah, so anoxic event are any event that turns the oxygen anoxic, that which means that it dissolves all the oxygen present in the water. Water has inbuilt oxygen. Why water is dangerous for preservation of organic material? Water is dangerous because it it has oxygen dissolved, and when you have oxygen, they will oxidized, and you will not get oil and gas. Okay, so presentation is visible. What?
No, sir.
Hmm. Okay, so I have written down the. Okay, when I'm putting it in presentation mode, then it is going out. Okay, no worries. We'll continue like that only. Okay, we will continue like this only. So I have written down the theory. What are the causes and what are the characteristics of an ocean basic anoxic event? I will discuss it a bit only. So any event that make the ocean anoxic, that is, for example, it is a volcanic eruption. Volcanic eruption releases a lot amount of CO2, and like you're burning something now. When you're burning something, you will consume oxygen, and when you consume oxygen, the water will become anoxic. So due to anoxic event, when the water will become anoxic, or then all the marine organisms that are present in the area will die, and they will ultimately get preserved if there is some deposition. उनको cover भी करना है. If you want to get petroleum, you need to cover those things with some soil. तो तुम्हारे पास फ्लो भी होना चाहिए, ये नहीं कि पानी में ही पड़ा है, तो पानी में पड़ा रहेगा तो वो अल्टीमेटली वो प्रिजर्व तो हो जाएगा, ऑयल में कन्वर्ट भी हो जाएगा, बट they will dissolve in the water. You will not get it in the rocks. You will not be able to extract it. So you need to cover it with soil. That's why burial is important. Okay, so this part is over, how organic matter is preserved. So if anybody has any question, they can open their mic and ask. Okay, so I will quickly pass this theoretical things. So this is about types of kerogen. Kerogens are basically the precursor of oil and gas. Okay, like some processed organic material which are preserved are called as kerogen. Okay, so there are four types of kerogen. This is type 1, type 2, type 3, and type 4. You can see the See the organism that constitute type 1 keratin. It is algae. Type 2 is phytoplankton and zooplankton. Type 3 is plants. And there is a type 4 also. It is not shown here in this figure. Type 4 is oxidized organic material. मतलब जो ऑक्सीडाइज्ड हो गया, मतलब वो जो साइकिल था ना, वो साइकिल के ऊपर वाला पार्ट, लाइक दिस पार्ट, ये पार्ट में आ गया, वो ये ऑक्सीडाइज्ड वाले पार्ट में आ गया, तो इसमें तेल और गैस नहीं बनेगा अगर कुछ है भी तो. Okay, and let me show the maturation path. So in the graph, you can see hydrogen carbon ratio and oxygen carbon ratio. It is actually oxygen by carbon and it is hydrogen by carbon ratio. So the maturation path is like this. Maturation path goes like this along the along these branches. Can I draw here? Okay, so these are the maturation paths. Maturation is increasing along this. As maturation increases with what? Maturation increases with temperature. Maturation increases with pressure. Pressure and temperature are the four most important thing to convert the organic matter into oil and gas. So with increase in pressure and temperature, this oxygen by carbon ratio will decrease and hydrogen by carbon ratio will also decrease. So in this part you can see the legend. This part is indicating oil. This part is indicating nothing. This is organic matter only. This part is gas. And when you increase the temperature a bit more, the organic matter will get oxidized and will constitute type 4, type 4 kerogen. And this graph shows the process, how the organic matter are converted into petroleums. So firstly there is microbial degradation, then polymerization. Polymerization is like the molecules bonds with each other. Then condensation. Condensation मतलब molecules छोटे हो जाते हैं. Condensation में क्या होगा, जो water के molecules है वो निकल जाएंगे, जो ऑक्सीजन के मॉलिक्यूल्स है वो निकल जाएंगे, and they get converted into these acids. Then this acids evolves into kerogen, and this kerogen upon and this kerogen when acted upon pressure and temperature, they get converted into oil. With increase in temperature, the oil converts like this. Oil converts into wet gas. Wet gas को और heat करोगे तो it will get converted into dry gas. Got it? Done?
Yes, sir.
Yeah. And this is the simplest steps: digenesis, catagenesis, metagenesis. These are the steps through which they are formed. Digenesis is a sedimentary process only, in which there is a reduction in porosity, there is compaction, so that
Sir,
water gets
slide
out.
is not visible.
Okay. Why is stopping again? Okay, so then catagenesis. Catagenesis is the principal stage in which oil and gas are formed. So this particular part, this is catagenesis only. So this is basic petroleum geology. You can read it from any book. So I will move to the main part, that is the industrial thing that is not written in any book. You can find it in books, but you will have to put a lot of effort. So let us start. So firstly, we will deal how exploration is done. You can find it in books, but like you will not get the details of the equipments used or the other nuances that we will be discussing. So firstly, everything of exploration starts with seismic in general. So what we do seismic surveys, and using seismic surveys, we get the structure of the earth, how the layers are arranged. So we get that in seismic campings. So how do we do seismic survey? We go to the area of interest. We put out some vibrators or some bombs that generate artificial vibration. This vibration gets into the earth surface, they get reflected back, and we record those reflections, at what time they went into the surface, at what time they are coming back. So according to the time of arrival, we get to know the depth of the surface. With increase in time, the depth must be increasing. With decrease in time, the depth must be decreasing. So using that technique, we identify the topography of the subsurface. So exploration start with seismic mapping. There are various types of seismic survey. You can read it somewhere. And then after we have done the seismic survey, we search for petroleum system, and we search for a hydrocarbon play. There are few components of petroleum system that we'll discuss in the next slide most probably. And and if all petroleum system are present at any place, then we can call it as a play. So this is the difference between petroleum system and play. Every petroleum system component, if present anywhere, it will be called as a play. So we will search if there is a play or not. If there is a play, then we will move forward. Otherwise, we will stop the exploration right there. And what are the petroleum system? Let me give an example. Like it constitutes reservoir rock, it constitutes source rock, constitutes trap, it constitutes seal, migration हुआ है कि नहीं हुआ है, migration pathways. These are components of the petroleum system. If everything is present, then you have the highest chance of getting oil and gas. If everything is present, then we go into analyzing migration and entrapment model. So we try to find where the oil might have been migrated. Oil gets generated at a source rock. Source rock is what? Any rock that is high in organic material. For example, shale. Shale is a source rock. Why shale is a source rock? Because organic material got preserved in this rock. Why organic material gets preserved in this rock? Because it has very less permeability. And due to less permeability, nothing can enter here. Oxygen cannot enter into this rock. Water cannot enter into this rock. And when oxygen and water cannot enter into this rock easily, the organic material that was present in this rock get preserved, and that's why shale are source rock. There are other source rock also. Limestones are also source rocks. So this is how source rocks are made, and we then check off migration, where the oil formed at the source rock must have migrated. जो तेल यहाँ पे बना है यहीं पे नहीं रहेगा, वो कहीं पे जाएगा, migrate होगा. Why? It is governed by buoyancy. Everything tries to move towards its stable position. For example, this is the Earth. Let us say we are talking of a layer of Earth that is 1,000 kilometers, sorry, 1 kilometer below, 1,000 meter below. So its density will be what? 3.5 gram per cc. Let us say for an example, 3.5 gram per cc. And in the pores of this rock, you have put what? You have put oil and gas. You have put oil and gas and water in this pores. And the density of this oil and gas and water is what? 1.0 gram per cc. It is the density of water. And for oil, it is what? 0.8 gram per cc. So you are putting something very lighter, 1 gram per cc and 0.8 gram per cc in a rock which is this much dense, 3.5 gram per cc. So it will try to migrate towards क्या अपने साथियों को ढूंढना चाहेगा जहां इसका कंपैटिबल डेंसिटी मिलेगा. मतलब ये कम डेंसिटी की ओर मूव करना चाहेगा, मतलब ऊपर जाना चाहेगा. ये लिथोस्टैटिक प्रेशर के कारण तुम्हारा डेंसिटी इंक्रीज करेगा. यहाँ पे प्रेशर ज्यादा है. It will try to move to a place which is which is having less pressure. For example, if the layer is inclined like this, the pressure will be P2 here and the pressure will be P1 here. And this pressure P2 will be what? Higher than, sorry, the pressure, yeah, it was right. The pressure P2 will be higher than what? P1 because iska depth ज़्यादा है. So anything that was present here, they will try to migrate here. Okay. To decrease its pressure. to move towards a more stabler position. Done. And then we will discuss about a depositional model. Depositional model tells about like the environment in which the sediments were deposited. This is very important to study because इससे से पता चलता है कि कैसा environment था, तो वहाँ तेल और गैस का deposition होगा तो वो preserve हुआ होगा या नहीं हुआ होगा. Then on the basis of deposition model, we prepare sand isolates map. What is sand isolates map? A map connecting lines of equal showing lithology. You can say is as simply as that. Showing lithology like sand, sail, etc. Then we prepare a geological model. Geological model constitutes what? Geological model will constitute layers. It will constitute faults. Okay. So we need a geological model to access where to put the well, where to put the well, which is the most favorable position to put the well. How many wells how many wells we can put to get the oil, how to maximize the recovery. So everything is done in the geological model. And then before drilling the well, we do a prospectivity analysis and geological risk assessment to see what is the chances of success of the exploratory well. After this, we do a techno-economics. We see whether the well is economically feasible or not. If the well will produce, will be able to bear the cost of the drilling. So we'll do a techno-economics. And then we will see some constants also, logistic resource and environmental constants. And then we proceed for the exploratory drilling. And when drilling is done, then comes the more difficult part: logging, production testing, and well completion. These three processes needs a lot of decision making. You will record the logs, the basic logs: SP, gamma, density, porosity, sonic. You will record these logs and you will analyze whether oil is present or not. And once you have decided oil is present, you will do the other steps like perforation and all. We will discuss later. And then you will go for production testing, that is activating the well. And once the well has activated, we can go for what? We can go for completing the well. That is, we can take production from the well. Moving on, this is how what a seismic section looks like. Seismic campaign से ये result मिलता है आपको. You get the topography of the subsurface, and this is the work of geophysicist. They acquire the seismic surveys, they process the seismic surveys, and with the help of geologists, they interpret these things. They interpret the seismic surveys. Like they have marked the layers, no? They have marked this layer green, yellow, sorry, green, blue, yellow. They have marked the faults. This F2, F13, F1. These all are what? These all are faults. Okay. You can see a rollover structure here. So once this is marked, we convert this into a geological model. And later we work in the model only. We don't go back to the seismic again. If we have to relook something, then only we will go back to the seismic. Otherwise, once geological model is prepared, we will work in the geological model only. Okay, we will prepare the model. This is particular section. This is a particular slice. You are seeing just a single slice. There are many other slices. There are many other slices other than this, and joining the surfaces along many slices, you will get the surface. For example, in this slice, like I am drawing the green line, you got the green line like this. In another slice, you got the green line like this. Another slice, you got the green line like this. So ultimately, joining all the green lines across all the slices, you will get the surface. So this is how the surface of this green line looks like. This is the actual topography of this green line. So you make maps like this. So this seismic sections helps in making structure contour maps. Okay. Any questions?
Sir,
Hmm.
sir, we have a question here from Aiko
Yeah.
Roy. As we are a
Yeah.
student-led organization, So if anyone targets to join ONGC or oil industry, then what is the procedure?
Acha. Okay, let's take this question and the end only.
Okay, sure, sir.
Yeah, done. And then let's move into the depositional model. This is a depositional model. So depositional model is what like like it is a 3D model where we show what is the type of the sediment, what is the what is the type of the environment in which the sediment is deposited. By seeing the sediment, you can tell that it is of lake origin, or it is of swampy origin, or it is of river origin, because the other contents will vary. For example, by looking at the logs also, you can interpret the depositional environment. You must be knowing about GR logs, or you will read it in geophysics. GR is what? Gamma ray log. Gamma ray log. Each rock, everything emits gamma ray. Every rock emits some amount of gamma ray. Like everything is radioactive in this particular earth. And everything emits radiation. So everything emits gamma radiation. There is no exception. Okay. So everything emits a gamma radiation. So every rock emits gamma radiation. And there is a particular feature like the shale rocks. Shale rocks have high gamma values. They emit high amount of gamma radiation. And sands, for sands, the gamma ray is low. For limestone, the gamma value is further lower. And to measure the gamma ray, we use GM counter and all. GM counter is an instrument. We can use it to measure the gamma rays. Okay, so by seeing at the logs, you can determine the environment. For example, if the log is blocky, like the log is not varying much like this only, like the first one, the cylindrical and boxy, you can tell it as it must be a fluvial channel, carbonate shelf, submarine canyon, field, prograding delta, etc. So similarly, for other logs, it is written. Like aggrading is what? Aggrading is like but just depositing, no variation. And then there is progradation. That is the sediment. That is the gamma ray is what? The gamma ray is decreasing. Gamma ray is decreasing. Gamma ray is decreasing means that you are moving towards sand. Here you have sand and here you have shale. That is coarsening upward. You can say it as coarsening upward. और अगर तुम नीचे की तरफ देखना चाहते हो तो you can tell it as fining downward. Okay. Then you have bell shape signatures. For bell shape signatures, you can say that the environment must have been these. And for hourglass signatures, you can say that the environment are these. So you can take a screenshot of this slide. And so, yeah, we can predict the deposition environment from log signatures also. There are other methods also, like you can take the sample. When we drill the well now, we take core samples, the lithology comes out. So by analyzing the lithology by for microorganisms, for example, foraminiferas, like different foraminiferas are of different origin. So you can predict the environment from there also by using microorganisms. Yeah. So the next step was after deposit metal model, we prepare isolith maps. This is an example of isolith map. So you saw this seismic section now. Using seismic section, you prepare a map. You prepare a surface map. And when you run different attributes, for example, there is an attribute called RMS, root mean square attribute. So when you run attribute, you get different features. For example, this is an isolith map, and this must be an attribute map. So these different colors are indicating different lithologies. For example, this red color must be a must be a particular lithology. This green is another lithology. This yellow is another lithology. So this is an isolith map showing different lithologies. Done. And then we come to geological model. This is how a geological model looks like. This also comes from seismic only, seismic sections. Like it has like this is a cross sectional view. The view that you are getting at the front, this is the cross sectional view, and this is what? This is the top view. You're seeing faults. You're seeing what you can see the deep direction. Like this is a fault. This is a normal fault. Normal fault कैसे बोल रहे हैं हम लोग? We are saying it is a normal fault because the in the direction of hanging wall, sorry, in the direction of dip, we are getting the hanging wall block. If in the direction of dip, if you are getting the hanging wall, then it is a normal fault. Otherwise, it is a reverse fault. So you're getting the fault. You can measure the dip. You are seeing the how the structure is varying. So going in this direction, it is getting deeper. So all of these things you can see in the geological model. For example, if you want to put a place, so you will look to a place which is shallower. क्योंकि तेल और गैस जब माइग्रेट करेगा, they will accumulate in a shallower position. You will find, you can see the positions here which is more shallower. What are the migration pathways? Faults are what? Faults are migration pathways. So you will analyze how the faults are structured, how the where the oil and gas must have been accumulated. You can analyze all those things from the geological model. Okay,
So
now
we have two
going,
questions
yeah, so
from Shorvujit Das. How to take internship in ONGC and from when we should check about it?
okay, so there are two internship in ONGC, two types of. There is summer internship and there is winter internship. Winter internship, I guess it is open in most of the ONGC centers. Like we publish the notification in our internal websites only. So you need to contact someone like who is working in ONGC to get the notification, and then you can apply for it. Otherwise, through your colleges, you can directly contact the ONGC center which is nearest to you. For example, if you're living in West Bengal, you can contact ONGC which is located in Bengal. You can send your mark sheets and all. You can fill up the form, you can attach your mark sheets and then apply. So once it comes in summer and once it comes in winter. And what are the most prominent deposition environment for search of hydrocarbon? So the most prominent is marine only. टेरेस्ट्रियल में हमें मिलता नहीं है बिकॉज यू नीड वोट यू नीड ऑर्गेनिक मैटर लैंड पे चीजें प्रिजर्व करना डिफिकल्ट है पानी में चीज प्रिजर्व करना आसान है बिकॉज पानी में बहुत कम ऑक्सीजन ऑक्सीजन होता है वो एक्सपोज नहीं होता सरफेस से so most of the reserves oil reserves that you are getting it you will get it in ocean or near to ocean for example you get a lot of oil in what Rajasthan why because Rajasthan is a self area once it was under the sea. Then you get oil in what? Assam. Why Assam? Also, it is a self area. Self is what? Self is the end part of a continent. Assam was also a self area in the past. That's why you're getting oil here. You are getting oil in Bombay High. Why you are getting oil in Bombay? Because Bombay is right now also a self. The oil is deposited in the self. Okay. You are getting oil in Kolkata. Why? It is a self area. So in marine, the chances are very high. In land, the chances are very, very low. If you're getting oil and gas in land, it must be close to marine environment. Okay, I have another question. In future, will AI play an important role in any activities that a geologist has to do in ONGC? Yeah, so let us complete this now first, and then we'll discuss. I will take the question of Udipan. Let's complete it. Yeah. So after geological model, we will go to the possibility of success of finding oil and gas. So this is a type of chart that we'll prepare. Just you guys have a look at this chart and I will be back in 2 minutes after drinking a glass of water. Take a look at this chart. So why, sir, then why in Durgapur, West Bengal, gas have been found in ONGC and Damodar Basin? Acha. So why it is not near to sea? Right now it is not near to sea. In past it must have been near to sea. It must have been close to sea. Rajasthan also in onshore, like in Ahmedabad you get oil. Ahmedabad is the largest onshore asset of ONGC. Like the production, the daily production is uh yeah, daily only. It is 5,000 tons. For Jorhat it is 750, 780, 800 tons. For Ankleshwar, it is 3,500 to 3,000 tons. Okay, so Ahmedabad is also not close to sea, but in the past it was. There must have been marine influence. There must have been transgression. Okay, so let us come back to the geological risk assessment sheet. You can tell me, you can check off a region which has a very less possibility of being close to. Let us say Madhya Pradesh, you don't have oil and gas here. Let us say Jharkhand, you don't have oil and gas here. And let us say, yeah, you can take any other state which is very landlocked. You can take Chhattisgarh, there is no oil and gas, and you will not be going to find any oil and gas there also in future also. Like there are sedimentary basins, there are 26 sedimentary basins in India which are prospective, and you can find all geological details about those sedimentary basin in the DGH website. I can show it to you. Like this is the website of Directorate General of Hydrocarbons. What you need to do is like you need to go to the geology part of this website. Here you can see Indian geology. Indian geology, then you can go into basin and categories. So basin are categorized into three types, and then you can go into basin informations like sedimentary basin. There are 26 sedimentary basin in India covering 3.4 million square kilometers. So basins are categorized into three types: category 1, category 2, category 3, based on the prospectiveness of those basins. Category 1 basins are what? Category 1 basins are those from which we are right now we are producing oil and gas. कैटेगरी टू और वो जिसमें हमें इंडिकेशन मिला है कि यहाँ तेल और गैस हो सकता है, बट हमने प्रोडक्शन चालू नहीं किया है अभी तक. फॉर एग्जांपल गंगा बेसिन से, ठीक है. हाँ, नदी के किनारे भी हो सकता है, नॉट नेसेसरली मरीन इन्फ्लुएंस. नदी के किनारे भी मिल सकता है तेल और गैस. ओके, सो दैट्स व्हाई वी आर फाइंडिंग ऑयल एंड गैस इन गंगा बेसिन. ओके, थोड़ा तुम्हें पानी का इन्फ्लुएंस चाहिए होगा फॉर प्रिजर्वेशन, और मरीन ऑर्गेनिज्म से ही बनता है तेल और गैस, एंड यू विल फाइंड मरीन ऑर्गेनिज्म दैट इन ऑयल, सॉरी इन वाटर ओनली. टेरेस्ट्रियल से नहीं बनता ऑयल एंड गैस. तुम वो टाइप कैरोजेंस के टाइप्स थे ना, कैरोजेंस के टाइप्स पे देख सकते हो. दिस इज अ टाइप ऑफ कैरोजन. टाइप 1 जो होता है कैरोजन, दिस गिव्स व्हाट, दिस गिव्स ऑयल. टाइप 2 कैरोजन जो होता है वो देता है ऑयल भी प्लस गैस भी. और टाइप 3 कैरोजन जो होता है वो कुछ नहीं देता है, वो देता है गैस प्लस कोयला. ठीक है, गैस प्लस कोल. सो यू कैन सी टाइप 3 कैरोजन में क्या आ रहा है, टाइप 3 कैरोजन में लैंड प्लांट्स आ रहा है. तो जहां भी तुम्हारा टेरेस्ट्रियल इन्फ्लुएंस होगा वहां तुम्हें गैस मिल सकता है, ठीक है, और कोल मिल सकता है, बट तेल नहीं मिलेगा. फॉर तेल यू नीड वुड, यू नीड लिपिड रिच कैरोजन, फाइटोप्लैंक्टन एंड जूप्लैंक्टन. देन you need what? Algae, Botryococcus and all. So you need to have a marine influence. For oil, gas you can get in terrestrial environment also. You are getting gas in Jharkhand also. You're getting gas in Madhya Pradesh also. All those gases are what? All those gases are from coal. So they are called as what? Coal bed methanes. So now coming back to this geology, sorry, DGS. We were discussing DGS now. So there are three types of basins: category 1, category 2, and category 3. Okay, so you can see the map where the basins are located. तो यही है प्रोस्पेक्टिव बेसिन्स हमारा, यहीं पे मिलेगा तेल और गैस. So you can see the number 22. 22 is what? 22 is Deccan syncline. Then 10. 10 is what? 10 is Vindhyan. Vindhyan में बहुत सारे नदी का influence है, ठीक है. And then here, like on the self areas, most of the basins are what? These are sedimentary basins only. These are not oil prospectiveness or any other thing. These are sedimentary areas, sedimentary basins. Okay, total 26 sedimentary basin है हमारे पास, और यहाँ प्रोस्पेक्टिविटी के हिसाब से बांटा गया है. ये देखो, जो लैंडलॉक्ड है वो मोस्टली पिंक कलर में है, दैट इज प्रोस्पेक्टिविटी कम है. जो जिनका प्रोस्पेक्टिविटी ज्यादा है वो कहाँ, सेल्फ एरियाज में. दिस वन, दिस वन, दिस वन, 4 and 3 and 6 also. And now you can go to the basin information section from Indian Geology and you can get a whole lot of details of each and every basin. Like what type of source rock are present there, what type of reservoir rock are present there, what is the reserve, what is the tectonic setting, how oil and gas are formed in that particular basin. You can get all the details from this particular website, from this particular PDFs. Coming back to our presentation. So before drilling any exploratory location, we analyze this thing, geological risk assessment sheet. In this, we analyze each of the parameters that contributes the petroleum system, that is source rock, reservoir rock, trap rock, seal rock and play dynamics. मतलब source rock होने के कितने chances हैं, ये 0 to 1 में क्लासिफाई किया गया है. 1 is what 100% and 0 is what 0%. तो सोर्स रॉक होने के कितने चांसेस है. फॉर एग्जांपल इन दिस असेसमेंट शीट यहाँ पे लिखा गया है कि सोर्स रॉक होने के पूरे पूरे चांसेस हैं. रिजर्वायर रॉक होने के क्या चांसेस हैं, थोड़े कम चांसेस हैं, 0.8 to 0.9. ट्रैप होने के चांसेस 0.8 to 0.9 है. सील होने के चांसेस भी 0.89 है. प्ले डायनेमिक्स के चांसेस व्हाट क्या है, 0.6 to 0.8. ओवरऑल पॉसिबिलिटी क्या इनका निकल के आ रहा है, 0.32, 32%. मतलब चांसेस है कि ये वेल ड्रिल करोगे तो 32% चांस है कि आपको ऑयल और गैस देखने को मिलेगा. अगर कोई भी एक चीज यहाँ पे नहीं रहता है, ये जो 6 पैरामीटर दिख रहे हैं, 1 2 3 4 सॉरी 5 पैरामीटर दिख रहे हैं, इनमें से अगर कोई भी पैरामीटर मिसिंग है, then you will not make any geological model, you will not make geological assessment sheet, you will not go for drilling. अगर सील नहीं है, ठीक है, फॉर एग्जाम्पल दिस इज एन एंटीक्लाइन, यहाँ सैंड है, ये सैंड है पूरा, यहाँ सोर्स है इसका, ये सोर्स है. अब यहाँ पे एक्युमुलेशन होना था, ठीक है, यहाँ पे ऑयल एंड गैस एक्युमुलेट होना था. बट ये ऑयल एंड गैस यहाँ पे तभी एक्युमुलेट होगा जब इसके ऊपर एक लेयर रहेगा जो कि इम्पर्मिएबल होगा, दैट विल सील दिस ऑयल एंड गैस. ये ऑयल एंड गैस को और ऊपर जाने से और ऊपर परकुलेट करने से कोई यहाँ पे रोकेगा, देन ओनली वी विल बी एबल टू फाइंड द ऑयल एंड गैस राइट नाउ, एज ऑफ नाउ. अदरवाइज वो पास्ट में ही वो परकुलेट करके सरफेस पे पहुंच गया, वो खत्म हो गया. तो अगर ये सील एब्सेंट है, if this seal is absent we will not get it. if reservoir rock is absent, तो रिजर्वायर रॉक ही नहीं है तो सोर्स रॉक से जो तेल निकलेगा, सोर्स रॉक से तुम डायरेक्ट तेल निकाल नहीं सकते हैं क्योंकि इसका परमिएबिलिटी बहुत कम है. तो यू नीड रिजर्वायर रॉक ही नहीं है तो तेल रहेगा कहाँ, सोर्स रॉक ही नहीं है तो मतलब तेल बना ही नहीं. प्ले डायनेमिक्स ही नहीं है. प्ले डायनेमिक्स मतलब जो माइग्रेशन में हेल्प करता है, कहीं कहीं थ्रस्ट हेल्प करता है, कहीं कहीं नॉर्मल माइग्रेशन भी होता है अलोंग द रिजर्वायर रॉक. अगर माइग्रेशन माइग्रेशन तो चलो ठीक है, माइग्रेशन अगर नहीं हुआ है तो वहीं पे रह जाएगा तेल जहाँ पे फॉर्म हुआ था. बट दिस पर्टिकुलर फैक्टर्स, दिस 4 factors are very necessary for accumulation of oil and gas. So we assign a probability factor to all these parameters and we see what is the possibility of the success. If possibility of success is greater than 30%, we go for drilling of the well. Done. And then we also do a techno-economics, whether it is economically viable or not, the technology that we are putting in. Like a drilling rig cost around 15 lakhs per day. This is the cost of running a drilling rig. So you are investing a lot of money. You will be investing around 35 crores of rupees for drilling a single well. So if you're investing this amount of money, you need to see whether the it is technically viable or not. अगर तुम्हें लद्दाख पे ड्रिलिंग करनी है, लद्दाख पे ड्रिलिंग करनी है तो ये 35 करोड़ नहीं रहेगा. You will need to move the rig. Rig is like very big now. It is like a 3-story building. You need to move the rig here. तो लद्दाख में अगर ड्रिलिंग करनी है, यहाँ पे रिग लगाना है, तो ये 35 करोड़ नहीं रहेगा, ये 60 करोड़ हो जाएगा. तो 60 करोड़ में वेल ड्रिल करना फिजिबल है क्या इकोनॉमिकली? यू विल सी दैट. तो दिस इज द थिंग दैट यू नीड टू एनालाइज. तो फैक्टर्स क्या कह रहे हैं कि तुम कितना रेवेन्यू जनरेट कर सकते हो. रेवेन्यू किस पर डिपेंड करेगा? तुम्हारे क्रूड ऑयल प्राइस पर डिपेंड करेगा. फॉर एग्जांपल अभी $60 के आसपास चल रहा है पर बैरल. ओके, लेट अस से $60 पे लद्दाख में ड्रिल करना पॉसिबल नहीं था. क्रूड ऑयल प्राइस लेट अस से $110 हो जाता है, तो शायद फिजिबल होगा, तब हम यहाँ जाके ड्रिलिंग करेंगे. तो ऑल डिपेंड्स ऑन द पैसा. Now moving to the less important things, logistic, resource, and environmental constant. So logistic is what we need to move the rig. So we most of the time we will be able to move the rig in plain areas, and in geologically tough terrains, rig movement is a challenge. Like you cannot go to some pahad and pahad etc to drill the well. Transportation is a challenge. You will not get roads everywhere. Then EC and FC is a challenge. EC is what environmental clearance, FC is what forest clearance. If your if your oil and gas field is falling in a forest area, or it is of environmental concern, then you will need to get this clearances from government to drill the well. Then there is CTO and CT needed for any establishment that you're making. If you're opening any business also, then you need to what? You need to get CTO and CT from state government, Pollution Control Board. CTO is what? Consent to operate, and CT is what? Consent to execute. So you need to get these clearances. Now, now if everything is cleared, the probability of success is greater than 30%, then we go for exploratory drilling. So exploratory drilling में कितना time लगता है? So in general, a drilling of a well takes around 2 months. हम लोग कितने डेप्थ तक करते हैं? इन जनरल इंडिया में जो ऑनशोर ड्रिलिंग होता है वो 3000 डेप्थ तक भी होता है. अहमदाबाद में जो जहाँ पे लेयर्स बहुत ऊपर है, वहाँ पे 600-700 मीटर में भी ड्रिल मिलता है. नहीं तो हम लोग वी गो एज डीप एज 3000 मीटर्स. ड्रिलिंग प्रोसेस क्या होता है? ड्रिलिंग प्रोसेस में एक बिट होता है जो अंदर जाता है, एंड दैट कट्स थ्रू द जियोलॉजिकल सेक्शंस. देयर फेजेस आर व्हाट फेजेस, मतलब हम लोग 3 फेज में ड्रिल करते हैं. फर्स्टली हम लोग एक बड़ा होल करते हैं, लेट अस से this much. We drill the hole like this. This is the hole. Done. Once we are done drilling, we put casing. क्योंकि अगर हम होल यहाँ से निकाल मतलब यहाँ से अर्थ मटेरियल यहाँ से निकाल दिए, what will happen? This hole can collapse. So to prevent it from collapsing, what we do? We put cylindrical metallic tube here that are called as what? That are called as casings. Casing डाला हमने, ठीक है. फिर छोटे बिट से ड्रिल करते हैं. लेट अस से 2 फेज का ड्रिलिंग है, छोटे बिट से ड्रिल कर रहे हैं. फिर से हमने ड्रिल किया, फिर से ड्रिल कर लिया. देन अगेन ये कोलैप्स करने का इसका चांसेस है, तो हम क्या करेंगे? फिर से केसिंग डालेंगे. यू विल पुट अ केसिंग हियर. केसिंग हमने डाल दिया, ये वेल हो गया, ये वेल बन गया आपका. और ये जो केसिंग और ये तुम्हारा क्या है? सरफेस, अर्थ का सरफेस है. दिस अर्थ. And blue is what? Blue one is your casing. That is the metallic thing. इनके बीच में हम क्या डालते हैं? इनके बीच में हम डालते हैं सीमेंट. Here you will put the cement to keep the casing intact. यहाँ पे हम सीमेंट डाल दिए फॉर एग्जाम्पल, डाल दिया. उसके बाद इधर रॉक लेयर्स हैं आपके, ठीक है. ये रॉक लेयर्स हैं. एंड देन लेट अस से कि आपका ये जोन प्रोस्पेक्टिव है, ये जोन में तेल है. what will do, you will perforate the casing here. Perforate means you will make holes in the casing here. When you will make holes in the casing, the oil will come out. The oil will come out and will go up, and when it will come up, we will take the production. So this is how drilling works. And in ONGC, like, geologists are recruited as in many position, and one of the position is well site geologist. Well site geologist does what? When ड्रिलिंग इज बीइंग डन, जब ये ड्रिलिंग हो रहा था तो ये बड़ा सा हमने होल क्रिएट किया, फिर ये होल क्रिएट किया, तो ये होल से जो भी अर्थी मटेरियल बाहर आया है इनको एनालाइज करना होता है. दे सी व्हाट दे सेट इन द साइट ओनली, दे एनालाइज द लिथोलॉजी. तो लिथोलॉजिकल डिस्क्रिप्शन आपको अगर टीचर लिखने बोलता है क्लास में, तो यू शुड टेक इट सीरियसली, you should do the mineralogical practical seriously, like see, like the microscope things. You need to see the lithology from the microscope. That you need to write the description, whether it is sand, whether it is shale, whether it is muscovite, any other mineral is present, whether that is glauconite. So you need to analyze the lithology. You need to mention the sorting of the grains. You need to mention the size of the grains. You need to mention the color of the grains. So you need to do all those things, and then you need to check the hydrocarbon source. ये जो अर्थी मटेरियल तो यहाँ से हम लोग निकाले हैं, अगर इस पर्टिकुलर पार्ट से जो अर्थी मटेरियल निकाले हैं, तो इसमें भी तो हाइड्रोकार्बन लगा होगा, दैट इज ऑयल एंड गैस लगा होगा उसके पोर्स में, तो इट विल हैव सम सिग्नेचर. सो ओके, सो दिस इज चेक्ड इन फ्लोरोस्कोप. ओके, व्हेन यू पुट इट इन फ्लोरोस्कोप it will shine. Okay, मतलब because oil is a fluorescent material, you will, if you put it in fluoroscope, it will shine. So this is the role of well site geology. They check hydrocarbon source, they check the lithology. There are other roles also, but this is the main role that you can study in your masters also. Like, you need to focus on the mineralogical things, you need to focus how to use microscope, how to identify different kinds of minerals. So this is how exploratory drilling is done and the role of well site geologist. Now moving to the next section, this is log. This is what we record. जब ये होल हो गया था, होल केसिंग करने से पहले, होल में हम केसिंग डाल दिया, ये ब्लू कलर वाला केसिंग, ये ब्लू कलर की केसिंग डालने से पहले we lower down tool, we lower down recorders inside this hole and record logs. And this is how a well log looks like. You can see the different types of log. This green is one word, this green is gamma ray. And then CNCF, this is what CNCF is, porosity. ZN is what? ZN is your density. P is what? Photoelectric factor, ये छोड़ दो अभी के लिए. And then these are what? These are resistivities. This is saturation of water. ठीक है. This is again porosity. And these are interpreted lithology from the logs. गामा रे से तुम लिथोलॉजी प्रेडिक्ट कर सकते हो बेस्ड ऑन द स्पेक्ट्रल सिग्नेचर्स. ठीक है, अब ये वेल लॉग को एनालाइज करके यू नीड टू डिटरमाइन वेदर ऑयल और गैस इज प्रेजेंट हियर और नॉट. ठीक है, अब तुम्हें सैंड आइडेंटिफाई करना है. सैंड में क्या होता है? सैंड में गामा कम होता है, तो यू कैन सी द गामा इज लो हियर, तो दिस इज सैंड. ओके, और जिस पर्टिकुलर सैंड में तुम्हारा ऑयल और गैस रहेगा उसका डेंसिटी डिक्रीज कर जाएगा. सैंड में क्या हो सकता है? ये सैंड है, दो सैंड है, सैंड के पोर्स हैं. एक के पोर में वाटर है और दूसरे के पोर में ऑयल है. ये सैंड 1 है, सैंड 2 है. आंसर फ्रॉम द ऑडियंस, दोनों में से कौन से सैंड का डेंसिटी कम होगा? एक के पोर में वाटर है और दूसरे के पोर में ऑयल है. फ्रॉम द ऑडियंस.
ऑयल होगा।
गुड, बिकॉज ऑयल का डेंसिटी ऑलरेडी कम है. ऑयल का डेंसिटी कम है तो इसका ओवरऑल डेंसिटी इस सैंड का जो होगा वो कम होगा एज कंपेयर टू सैंड 1. इसका डेंसिटी घट जाएगा. एंड देन वी टॉक अबाउट पोरोसिटी. पोरोसिटी, अगर ये सैंड है तो इसका पोरोसिटी ऑब्वियसली ज्यादा होगा. यू कैन सी इट हियर आल्सो. पोरोसिटी सेल में भी दिख जाता है, बट जो डेंसिटी होता है वो डेंसिटी मेजरली तुम्हें डिस्टिंक्ट दिखेगा सेल और सैंड में। अब यहाँ पे देखो, ये रेड वाला है, व्हाट रेड वाला डेंसिटी का लाइन है। ये ये यहाँ पे गामा रे हाई है 8100 फीट पे। 8100 फीट पे आप देखो गामा रे क्या है, बहुत हाई है। ठीक है, गामा रे कहाँ से कहाँ तक रेंज कर रहा है, 0 से 150। तो फॉर एग्जाम्पल यहाँ पे गामा 140 है, तो 140 पे आप देखो डेंसिटी क्या हो रखा है, हाई हो रखा है बहुत। हमें हाई डेंसिटी नहीं चाहिए, तेल और गैस में क्या होगा, डेंसिटी लो होगा। अब यहाँ पे थोड़ा सा और नीचे आते हैं, ये स्टेप पे आते हैं, ये पॉइंट पे, तो यहाँ पे डेंसिटी घट गया। तो दिस मीन्स दैट सिग्नेचर है कि यहाँ पे कुछ लाइटर मटेरियल है सैंड के अंदर। दूसरा सिग्नेचर क्या था कि यहाँ पे गामा रे घट गया। गामा रे घटने का मीनिंग है कि यहाँ पे ये रिजर्वायर रॉक है, सैंड है, गामा रे घट गया। ऊपर से डेंसिटी भी घट गया, मतलब सैंड के अंदर क्या है, सैंड के अंदर तेल है। अब और तेल कैसे हम बोल रहे हैं क्योंकि यहाँ भी गामा रे वैसे ही है, सिमिलर है। ठीक है, बट यहाँ पे डेंसिटी उतना नहीं घटा है। इस पार्ट में आप देखो, इस पार्ट में डेंसिटी हाई है, बट इस पार्ट में डेंसिटी लो हो गया है। दिस मीन्स कि ये भी सैंड है, बट ये सैंड में इसके अंदर पानी होगा, बट ये पार्ट ऑफ सैंड में इसके अंदर तेल होगा। दूसरा तरीका इसको जानने का क्या है, इसको इसके कंफर्मेशन के लिए आप डेंसिटी तो से तो प्रिलिमिनरी आइडेंटिफिकेशन हो गया तेल और गैस का। अब फिर से हमें और एक फैक्टर ऑफ आइडेंटिफिकेशन अगर चाहिए, तो वी विल सी द रेसिस्टिविटी कर्व्स। तेल का रेसिस्टिविटी ज्यादा होगा या फिर पानी का? एनीबडी फ्रॉम द ऑडियंस?
आई थिंक तेल का ही होगा।
ऑयल का ज्यादा होगा।
राइट, बिकॉज ऑयल इज व्हाट, ऑयल इज ए नॉन कंडक्टर ऑफ इलेक्ट्रिसिटी। तो नॉन कंडक्टर है तो इसका रेसिस्टिविटी ज्यादा होगा। वाटर इज ए कंडक्टर ऑफ इलेक्ट्रिसिटी, तो ये तो इलेक्ट्रिसिटी को कंडक्ट कर लेगा, तो रेसिस्टिविटी ज्यादा दिखाएगा नहीं है। तो यू गैस कैन सी इट हियर, ये पार्ट में आप देखिए, ये पार्ट में रेसिस्टिविटी हाई हो रखा है, मतलब इस पार्ट में तेल भरा हुआ है। जबकि ऊपर वाले पार्ट्स पे देखो, ये भी सैंडी है, इतना खराब नहीं है, ये भी सैंडी है, बट यहाँ पे रेसिस्टिविटी क्या है, लो है, बहुत कम है। रेसिस्टिविटी का मतलब क्या है, यहाँ पे पानी भरा होगा। ये पार्ट भी सैंड है, नीचे वाला पार्ट 1850 8150 फीट वाला भी, बट वहां भी रेसिस्टिविटी लो है। सबसे मैक्सिमम रेसिस्टिविटी हमें इसी पार्ट में मिलने दिख रही है, हाईलाइटेड पार्ट पे। तो दिस इज हाउ वी आइडेंटिफाई ऑयल एंड गैस जोन। हमने आइडेंटिफाई कर लिया ऑयल एंड गैस जोन। हमने एक बार जब आइडेंटिफाई कर लिया ऑयल एंड गैस जोन, देन वी डू व्हाट, वी डू परफोरेशन। हमने बताया ना, अगर यहाँ पे तेल मिल गया तो वी डू परफोरेशन। परफोरेशन करेंगे तो तेल ऑटोमेटिकली बाहर आएगा, बाहर आएगा, देन हम फिर प्रोडक्शन ले लेंगे। ये तो हो गया। और भी बहुत सारे नुएंसेस, और भी बहुत सारे लॉग्स रिकॉर्ड करते हैं हम लोग, सोनिक लॉग रिकॉर्ड करते हैं। ठीक है, फिर डीप मीटर्स लॉग्स भी होते हैं एक्सप्लोरेटरी वेल्स पे। और लैमिनेशंस जानने के लिए और भी अलग टाइप्स के लॉग होते हैं, बट वो हाईटेक लॉग्स है। दिस आर द बेसिक लॉग दैट आर रिकॉर्डेड इन एवरी वेल। गामा, पोरोसिटी, डेंसिटी, रेसिस्टिविटी, दिस आर द बेसिक लॉग दैट आर रिकॉर्डेड इन एवरी वेल। तो ये देख के आप ऑयल एंड गैस जोन आइडेंटिफाई कर सकते हो। उसके बाद यहाँ लिखा हुआ OWC। OWC क्या होता है, ऑयल वाटर कॉन्टैक्ट। ऑयल और वाटर का कॉन्टैक्ट कहाँ पे है? ये सैंड है, ये सैंड का कोई लेयर है, दिस वन। इस सैंड में पूरा तेल नहीं भरा होगा। जो तेल होगा, अगर ये पोर्स में तेल है, ये पोर्स में तेल है और पोर्स आपस में कनेक्टेड है। पोर्स में तेल है और पोर्स आपस में कनेक्टेड है। पोर्स आपस में कनेक्टेड क्यों है, क्योंकि ये सैंड है। तो पोर्स अगर आपस में कनेक्टेड है, तो तेल क्या होगा, तेल ऊपर वाले पार्ट में बैठ जाएगा जाके, बिकॉज तेल इज व्हाट, तेल इज मोर बोएंट। तेल का डेंसिटी कम है, 0.8 है, पानी का डेंसिटी 1 है। तो तेल ज्यादा हल्का होने के कारण, ठीक है, वो ऊपर वाले पार्ट में एक्मुलेट कर जाएगा सैंड के, और पानी क्या होगा, नीचे वाले पार्ट में एक्मुलेट करेगा। एंड दैट यू कैन सी इन दिस पर्टिकुलर फिगर ऑल्सो। ये सैंड कहाँ से कहाँ तक कंटिन्यू कर रहा है, लेट मी, yeah, see, like this sand is continuing from this depth, red one, to this depth. सैंड कंटिन्यूअस है, गामा में कुछ खास वेरिएशन नहीं है। ठीक है, बट अचानक से इस डेप्थ के बाद यहाँ पे ये फीचर्स ही खत्म हो गया। ठीक है, मतलब यहाँ से मतलब ये जो बलून है, बलून पतला हो गया। बलून पतला होने का मतलब क्या है कि जो यहाँ पे मटेरियल है उसमें उसका डेंसिटी उतना भी कम नहीं है जितना ऊपर वाले का कम था। तो जितना बड़ा ये क्रॉसओवर होगा उतना ज्यादा चांसेस है कि जो मटेरियल है सैंड के अंदर वो बहुत ज्यादा हल्का है। सबसे ज्यादा हल्का क्या होता है? गैस होता है। तो चांसेस है कि ये पार्ट गैस हो, ये पार्ट ऑयल हो। ये प्रेडिक्ट कर लिया हमने। ठीक है, बट रेसिस्टिविटी कर्व को देखो आप एक बार। रेसिस्टिविटी कर्व से अंदाजा लगेगा। रेसिस्टिविटी का इन जनरल रूल क्या है? जैसे 5-6 का रेसिस्टिविटी आता है, रेसिस्टिविटी का यूनिट होता है ओम मीटर, OHM एंड देन मीटर। ठीक है, रेसिस्टेंस का ओम होता है, रेसिस्टिविटी का ओम मीटर। जब रेसिस्टिविटी कर्व को देखेंगे तो रेसिस्टिविटी कर्व ये ब्लू लाइन तक ही हाई है, उसके बाद अचानक से लो हो गया। बट सैंड तो है, सैंड तो उसके नीचे भी है, बट ब्लू लाइन के बाद रेसिस्टिविटी अचानक से कम हो गया। दिस मीन्स कि ब्लू लाइन के नीचे क्या है? ब्लू लाइन के नीचे कोई दूसरा मटेरियल है। और रेसिस्टिविटी देख के हम क्या बता पा रहे हैं? सैंड के अंदर क्या है? पानी है। ये पानी का रेसिस्टिविटी है 5-7 ओम। और ये कहाँ तक जा रहा है? 20-25 ओम तक जा रहा है, 40 ओम तक जा रहा है। तो ये पार्ट, दिस पार्ट इज वॉट ऑयल, दिस पार्ट इज वॉट वाटर। तो ऑयल और वाटर के कॉन्टैक्ट को क्या बोलते हैं? OWC। एनी क्वेश्चंस फ्रॉम दिस स्लाइड?
No, sir. Carry on.
Okay, moving on to the next slide. This is well log correlation. Correlation is what? Correlation is connecting the similar sands in different wells. So we, इसमें क्या है? ये आर्टिस्टिक थिंग है। वही अच्छा जियोलॉजिस्ट बन पाता है who has a sense of what? Sense of art। वो जो चीजें अच्छे से देख के समझ पाए। ठीक है, टैलेंट उतना ज्यादा काम नहीं आता है। You need to be a bit artistic. You need to identify things. You need to see beyond what is written. For example, like this is simple correlation. You can simply you can do it also. For example, in this particular thing, let me take a pointer. Correlation is what? Connecting sands which are same, or connecting formations which are same in different wells. Okay, so यहाँ पे तो correlation क्या हुआ है? This blue line is connecting this sand and this sand. These are what? These are the same sands. ठीक है, ये पॉइंट को आप लोग ढूंढ के दिखाओ दूसरे वेल्स पे। इन वेल कोपिया सी, at which depth I can get this sand? This is correlatable to which place in Kopia C sand? Kopia C well. This sand is occurring at which place in Kopia C well? Which depth? You can tell me the depth in Kopia C. You guys can try. You guys can guess also.
Sir, is it at 2400 depth at Copia B?
कोपिया बी में नहीं, कोपिया बी तो चलो ठीक है, कोपिया सी में, कोपिया बी इज ओके, I told it right.
Okay.
And कोपिया सी,
Is it 2800?
2800, sir, I guess.
right, it is at 2800. तो ये सिग्नेचर पकड़ने के लिए हम क्या करेंगे? दो चीजें करेंगे। ठीक है, पहले तो हम वो फीचर को चेक करेंगे जो फीचर की हम बात कर रहे हैं, ये सैंड ढूंढने की कोशिश करेंगे। दूसरा हम उसके ऊपर का पार्ट भी देखेंगे कि कोपिया ए में ऊपर का पार्ट जो है वो कोपिया बी में भी सेम है कि नहीं है। फिर ये सैंड के नीचे का पार्ट भी मैच करना चाहेंगे, बिकॉज सारे लोग तो वैसे ही दिखते हैं। यहाँ इसको भी देखोगे तो ये भी ऐसा ही दिख रहा है, बट you need to match the upper parts also, you need to match the lower parts also to get sure that it is the same sand. So this is correlating like this. घटिया drawing. Just a sec. So correlation helps in what? Correlation helps in finding the structure. Okay, you can see the topography of the layer. You can see how the layer is oriented. So I'm drawing it, the sand only. So this is the morphology of the sand. The sand is like this. मतलब बीच बीच वाले पार्ट में क्या है, ऐसे धसा हुआ है, दैट इज इनफॉर्म टाइप्स है, एंड देन साइड वाइज इट इज एंटीक्लिनल, एंड इट इज फॉलोइंग द सेम टोपोग्राफी एज दैट ऑफ दिस पर्टिकुलर सैंड जो रिजर्वर टॉप लिखा हुआ है। तो अगर ऊपर वाले का ट्रेंड मैच कर रहा है तो दिस मीन्स दैट योर कोरिलेशन इज ट्रू। अचानक से ट्रेंड चेंज नहीं हो सकता है। अगर अचानक से ट्रेंड चेंज हो रहा है तो दिस मीन्स कि आपने कुछ गलती की है या फिर वो जियोलॉजिकली कॉम्प्लेक्स है रहा है। फॉर एग्जाम्पल लेयर ए इज गोइंग लाइक दिस, ठीक है, layer is going like this, layer B is going like this, so layer C can't go like this na. In well A, 1, this is 1 and this is 2. Between 1 and 2 the layers are like this. A is going up. In 2 we got A shallower, in 2 we got B shallower. तो अचानक से नहीं होगा कि 2 में C deeper मिल जाएगा। मिल सकता है, देयर आर चांसेस, तो मिलेगा भी, तो बहुत ज्यादा सिग्निफिकेंट डिफरेंस नहीं होना चाहिए। अगर सारे लेयर्स को तुम सैल्वर इनकाउंटर कर रहे हो एक पर्टिकुलर वेल पे, तो अचानक से रिवर्सल नहीं होगा डिप का। तो यू कैन सी लाइक दिस इज फॉलोइंग द सेम ट्रेंड एज दिस वन, so this means that our correlation holds, our correlation is right. इससे तो हमें एक तो स्ट्रक्चर पता चलता है उस लेयर का, और हमें फ्यूचर स्ट्रेटेजी में भी काम आता है। अगर ये लेयर नीचे जाएगा तो इसमें हमें ऑयल मिलने के चांसेस कम होंगे, है ना। फॉर एग्जाम्पल, सैंपल तो कैसे ही बताऊं यहाँ पे, हाँ ठीक है। ठीक है, let me take another slide. For example, this is the resistivity curve and this is the gamma curve. Okay, of a particular well, and the resistivity curve is this is gamma and this is the resistivity. तो resistivity is decreasing at this point, तो this means कि ये part तुम्हारा oil होगा and ये part water होगा, and this will be what, this will be your OWC। ठीक है, फिर से एक वेल ड्रिल किए तुम, लेट अस से ये सैंड का टॉप मिला तुम्हें धरती के नीचे, ये सैंड मिला 2080 मीटर नीचे, ठीक है, मीन सी लेवल से। फिर तुम दूसरा वेल ड्रिल किए, वो सैंड आया यहाँ पे, सेम सैंड तुम्हें यहाँ पे इनकाउंटर हुआ, यहाँ पे इनकाउंटर हुआ, दैट मीन दिस इज कोरिलेटेबल टू दिस प्लेस। अब इसका रेजिस्टिविटी, अब ये क्या हो गया, OWC। और पानी ना, पानी टोपोग्राफी को फॉलो नहीं करता, पानी इज ए स्ट्रेट लाइन, तो दिस विल गो लाइक दिस, दिस विल गो लाइक दिस। तो इस वेल में क्या होगा, इस वेल में आपको रेसिस्टिविटी ये पार्ट में मिलेगा और ये पार्ट में रेसिस्टिविटी पूरा गिरा हुआ मिलेगा। तो अगर वेल तुम्हारा डीपर इनकाउंटर हुआ है, इसका मतलब ये है कि तेल वाला पार्ट कम हो जाएगा। यहाँ पे तेल वाला पार्ट क्या है, कम हो गया। और नीचे अगर तुम जाते जाओगे तो तेल वाला पार्ट क्या होगा, पानी के अंदर ही चला जाएगा, मतलब तेल वाला पार्ट खत्म हो गया, यू विल नॉट गेट एनी पे एनी ऑयल. So that's why knowing the morphology of the layers is important, and that's why we do correlation. Done? Any questions? Okay, moving on to the next slide. And this is regarding production testing. Like I told, now we do perforation. So this is the formation. Okay, and this lines are indicating perforation. We have perforated. So when we do perforation, the material from the formations comes into the wellbore, and from the wellbore we take it out. So there are self-flowing wells and there are other types of wells also. Self-flowing wells are what, कि जिसमें हमें कुछ करना नहीं पड़ रहा है, तेल और गैस जो फॉर्मेशन से आ रहा है वो अपने आप ही ऊपर आ जा रहा है. तो एक्यूफर के बारे में आपने पढ़ा होगा ना. एक एक्यूफर होता है जिसमें पानी अपने आप आता है ट्यूबवेल तक. एक में क्या होता है कि मतलब जो स्प्रिंग जो बन जाता है, स्प्रिंग में क्या है कि पानी अपने आप ही ऊपर आ रहा है, आपको कुछ नहीं करना पड़ रहा है. तो आपने कभी कभी हैंडपंप देखा होगा. वो हैंडपंप क्या होता है, वो ऐसे चलते ही रह रहा है, वो हैंडपंप से हमेशा पानी गिर रहा है कंटिन्यूअसली. तो दिस मीन्स कि इसका एक्वीफर क्या है, एक्वीफर बहुत ज्यादा प्रेशराइज्ड है, जो पानी यहाँ तक लिफ्ट कर दे रहा है और वो अपने आप पानी गिरते जा रहा है. एक हैंड पंप क्या होता है, उसमें पानी यहीं तक है, पानी का लेवल यही है. तो उसमें क्या करना पड़ेगा, आपको पानी को पंप आउट करना पड़ेगा. ठीक है. तो एक तो सेल्फ फ्लोइंग वेल हो गया जिसमें पानी अपने आप आता है, दूसरा क्या हो गया, आपको पंप आउट करना पड़ेगा पानी. ऑयल वेल भी इस तरह होते हैं, दो टाइप के, एक सेल्फ फ्लोइंग जो अपने आप ऊपर आता है, दूसरे गैस वेल्स होते हैं. सॉरी, गैस वेल्स नहीं होते हैं. दूसरे वेल्स में हमें डिफरेंट स्ट्रेटेजीज अपनाने पड़ते हैं तेल और गैस को ऊपर लाने के लिए. फॉर एग्जांपल चापाकल, हम लोग भी चापाकल लगाते हैं ऑयल एंड गैस पे, एंड दैट आर कॉल्ड एज व्हाट, एसआरपी, sucker rod pumps. You can search it in net, the figo. They are like, the mechanism is like just like hand pump only. So the oil level यहीं तक आ पाया, हमें तो surface पे चाहिए, तो we put a SRP and we bring the oil to the surface. Other thing is what this figure explains. This is gas injection valves. ऑयल ऊपर क्यों नहीं आ पा रहा है, क्योंकि जैसे ये सरफेस है और ऑयल यहीं तक आ रहा है, तो यहाँ पे जो प्रेशर है P1 है, और ये जो हेड है, ये जो हेड क्रिएट हुआ ऑयल का हेड, ये हेड का प्रेशर क्या होगा, रो जी एच. और ये हेड का प्रेशर लेटर से P2 हो जा रहा है. एंड इफ P2 इज ग्रेटर देन P1, P2 नहीं है, आप पूरा ले लो, पूरे हेड को, तो पूरे हेड को ऊपर उठाना है ना. तो पूरे अगर हेड का प्रेशर P2 है एंड P2 इज ग्रेटर देन P1, तो तेल आ ही नहीं पाएगा ऊपर. यू नीड वॉट, फॉर सेल्फ फ्लोइंग वेल्स यू नीड वॉट, P1 इज ग्रेटर देन P2, पूरा हेड, ये हाइट को लेना है. ऑयल का डेंसिटी, ग्रेविटी एंड पूरा हाइट, ये हाइट, ये प्रेशर, पूरे हेड का प्रेशर, पूरे ये ट्यूब का प्रेशर, इफ इट इज लेसर देन द प्रेशर ऑफ द फॉर्मेशन, फॉर्मेशन के प्रेशर से ज्यादा है, दैट इज TF लिख दो, देन ओनली द वेल विल कम इनटू सेल्फ, जो कि रेयर होता है, बट ठीक है. जो पहला वेल होता है किसी भी एरिया में, वो सेल्फ में आ जाता है. अगर सेल्फ में नहीं आ रहा है तो क्यों नहीं आ रहा है, क्योंकि हेड को नहीं उठा पा रहा है. तो हेड को कम करने के लिए क्या करना पड़ेगा, रो जी एच को कम करो. रो जी एच पे हम लोग क्या कम कर सकते हैं फ्रॉम द ऑडियंस. P1 तो कांस्टेंट है, आप P1 को चेंज कर नहीं सकते हो, क्योंकि ये फॉर्मेशन का प्रेशर है, कुछ नहीं कर सकते आप इसका, लिथोस्टैटिक प्रेशर है ये. आप चेंज कर सकते हो P2 को. P2 इज रो जी एच. रो जी एच में हम क्या चेंज कर पाएंगे, अगर हमको तेल सरफेस पे चाहिए तो. Anyone from the class? Srijita, I guess Srijita was the coordinator of this meeting. Okay, no worries, I will answer. So there's one thing that we can do is, yeah, we can decrease the density. We cannot change the gravity, we cannot change the height. Height तो same है, उतना ही डेप्थ से निकालना है हमें तेल और गैस. We can change the density. how we can change the density? We can lighten up the oil. How we can lighten up the oil? कि अगर oil में हम कुछ हल्का चीज mix कर दे तो that is gas. तो ये valves हैं जिससे हम गैस इंजेक्ट करते हैं, और ये से बीच बीच में हम गैस डाल रहे हैं, तो ऑयल क्या हो रहा है, ऑयल हल्का हो जा रहा है, तो ये प्रेशर फिर मैनेज कर पा रहा है हेड को, फिर ऑयल हमारा सरफेस तक पहुंच पा रहा है. ठीक है. So this is how the cycle complete, the drilling part complete. Moving, yeah. Like I have prepared some problem statement for you guys. You can see this map, like there are fault seals. There's a fault that seals the formations, and there are dip closures and all. So we will go to the last one. So this is a map. This is a structure contour map. You can see the depths. So this is 3000, 3910, 38880. So it is that meter below the surface. जो ज्यादा होगा वो ज्यादा डीप है, जिसका वैल्यू ज्यादा है वो ज्यादा डीप है, जिसका वैल्यू कम है वो शैलोअर है, मतलब वो एंटीक्लाइन बना रहा है. अगर कंटूर के वैल्यू डिक्रीज कर रहे हैं एक डायरेक्शन में तो मतलब ऊपर जा रहा है. तो दिस आर द वेल लोकेशंस. ओके, तो यू गाइस नीड मी टू टेल कि आप कहाँ पे वेल डालना चाहोगे सो दैट वी कैन एनकाउंटर. मतलब ये मान लो कि जो पैरामीटर्स होते हैं तेल और गैस मिलने के सारे यहाँ पे हैं, सोर्स रॉक, रिजर्वायर रॉक, माइग्रेशन, ट्रैप, सील. Still where you will put the wells, where you will put it to get oil and gas, where the chances will be high. From the class, I'm putting the names. Anyone from the class? बताओ. पहला तो ये, पहली चीज तो ये है कि ऑयल एंड गैस हमेशा सैल्वर पोजीशन पे जाके ट्रैप होता है, तो यू नीड टू कीप दैट थिंग इन
बेसिन
माइंड.
टाइप स्ट्रक्चर जहाँ बन रहा होगा वहां पे मे भी.
बेसिन टाइप.
हाँ सर, जैसे कि कोर साइड में जो लो एरिया होगा हाइट का.
अच्छा, तो उसको तो बेसिन तो नहीं बोलेंगे ना, उसको तो फिर एंटी क्लाइन या एंटी फॉर्म बोलेंगे. बताओ पॉइंट
सिंक
से
लाइन
बताओ.
टाइप में. सिंक लाइन.
incline, देखो incline कैसा दिखेगा. Incline will look like this. Incline will look like this.
Excuse me, sir.
Sorry. Yeah, please.
Sir, I'm very sorry to interrupt, but actually we are a bit short on time. So if you
Yeah,
could just try to
yeah,
like wrap up.
it is the end of the presentation. I skipped a few
Okay, sir.
slides because the time is up.
Okay, okay, sir. Sure. Okay, sir.
Yeah,
Sure, sure. Thank you, sir.
yeah, okay. So this is the problem, student. You can try it in home also. So you need to look for a place that is making anticlinal structure, or you can say anti-formal structure. So this is an anti-formal structure. You can see like where the contours are decreasing. From here, the contours are 3840, and while going in this direction, the contour values are decreasing. Here, the contour value is 3820. So the structure is like this. So if oil will migrate, it will accumulate here. Similarly, you can find other places. For example, here the contour value is 3840, and here the contour value is 3810. So the structure is like this. ऊपर जा रहे हो तो salver हो रहा है. So here the accumulation can be. Here we can get the accumulation. Okay. And then, for example, here 3880 contour is there, here 3790. So the contour value must have been lower here also. So the structure is getting shallower in this direction. So you can get accumulation here. So this is how we place wells once we have the structure contour maps. So this is all for today. This is the last slide. If you guys have any question, you can put it up. Otherwise, thank you.
So, sir, we have a few questions that we would like to take up.
Yeah.
This is from Shalini Mondol. Sir, can you please tell a bit in explained way how to apply for industrial training in ONGC?
Okay, so बताया था इंडस्ट्रियल ट्रेनिंग दो टाइप्स के होते हैं ओएनजीसी में. वन इज विंटर इंटर्नशिप एंड सेकंड इज व्हाट समर. तो विंटर का भी फॉर्म आया हुआ है इन अक्टूबर नवंबर इट कम्स एंड इट स्टार्ट्स एट द एंड ऑफ नवंबर. And for summer, it comes around April and March, and it starts in May. So you can contact someone who is working in ONGC, or you can send a letter to ONGC by filling up the application form through your HOD, through your head of the department. So you can either send it directly through your head of the department, or you can get the application form, fill it, and then apply. Any other
Thank you, sir.
questions?
Yes, sir. Coming to the next question, is there any scope for geologists who are hard rock enthusiasts in ONGC?
Hard rock enthusiast. Yeah, you can. Okay, I talked about well site geologist now. So in well site geology, you need to check the lithology. So it is hard rock only. If you need to go to the field, like in general, the field work is a bit less here, but still, if you're working as a well site geologist, you will look at the samples, you will make reports from that, and if you're working in regional geoscience laboratories like there are many RGLs in ONGC. So in that place also you will work on foraminiferas, you will work on rockable pyrolysis, you will work on oil lab, you will work on sedimentology lab. So there you can look onto the rocks. So not field work as such, but still the materials you get below the earth, which are excavated during drilling, you can look. You have to look. You have to make reports on those. You have to analyze those things. So yeah, there is scope who are hard rock enthusiasts.
Thank you, sir. Coming to the next question by Debashish Parida. Could you please explain how sequence stratigraphy helps in oil and gas searching?
Okay, sequence stratigraphy. I talked about transgression now. Sequence stratigraphy is what? Sequence stratigraphy deals with the interplay between deposition and interplay between deposition and fluctuation in sea levels. So sea level, like we talked about preservation in Barred Ocean, na? Sea level was playing a role there. जहाँ पे सी टाइड ऊपर जा रहा था तो इट वाज water was getting deposited in the lake, in the nearby lake, and stratification took place due to salinity contrast. So that is one thing. Other thing is that using sequence stratigraphy you can identify sequence stratigraphic tracts like HST, high strand tract, LST, low strand tracts, other sequence boundaries, and different types of sequence stratigraphic tract have different petroleum prospects. Different types of tract make different parameters. Like you need to study those things in sequence stratigraphy. सोर्स रॉक कौन से ट्रैक्ट से बनता है, रिजर्वायर रॉक कौन से ट्रैक्ट से बनता है, ट्रांसग्रेशन में कौन सा ट्रैक्ट बनता है, whether it is proliferous or not, रिजर्वायर रॉक कौन से ट्रैक्ट में बनता है. Yeah, it helps a lot. Another thing is that sequence stratigraphy is used in correlation also by identifying the HSTs, by identifying the TSTs. In difficult correlation, we incorporate sequence stratigraphy. Otherwise, also it helps a lot. but it is a bit a research type of thing. It is not generally done, but if you do it, then you can get good results.
Okay, I see. Thank you, sir. And next two questions are there from Uddipan Maji. What kind of work does a geologist do in ONGC? And in future, will AI play an important role in any activities that a geologist has to do in ONGC?
Okay, briefly, I'm saying so. There are three to four types of roles that geologists do in ONGC. First one is well site geology that I already talked about. You analyze the lithologies, you check the hydrocarbon source, and the second is you work in regional geoscience laboratories where you can do megascopic studies, you do macroscopic studies, you make thin sections, you prepare reports, you prepare depositional models. So this is the kind of thing that you will be doing in sedimentology labs. Other thing is you can be posted in basin, like we call it basin. So in basin you will do what? You will make maps, structure contour maps, you will make isopay maps, you will analyze the seismic section. We discussed the seismic section now, where we identified faults and all. So you will help the geophysicist identifying in faults, tracing the origins, making maps. We're doing well log correlation. So this is the third role. Other role is you will be posted in asset, and you will be working as a development geologist. Developmental geologist does what? Once a field is explored, once we have proven that oil is there, so the role of development geologist is to put infill wells. नेक्स्ट वेल हम कहाँ डाल सकते हैं? एक्सप्लोरेटिव वेल से तेल तो मिल गया कि हाँ एस्टेब्लिश हो गया कि इस एरिया में तेल है. अब उस तेल को कैसे, किस स्ट्रेटेजी से निकालना, कहाँ पे डेवलपमेंट वेल ड्रिल करना है, and they get involved in the whole process of drilling. They decide the zones, they do well log correlation, they update the maps. So this is the role. And yeah, I guess this much only. Yeah, AI. What future will AI play? AI can help you in easing out your work. For example, log correlation. You can automate the log correlation. You can give parameters in your input. That गामा का वैल्यू 80 रहेगा तो तुम उसको सेल मान लेना, 40 रहेगा तो सैंड मान लेना. ये इनपुट तुम डेटा प्रोवाइड करो उसको. ठीक है. फिर वो कोरिलेट करके तुम बता दो कि दिस वेल इज, इफ ऐसा फीचर रहेगा तो दिस इज ऑयल बेयरिंग. इफ ऐसा फीचर रहेगा तो दिस इज गैस बेयरिंग. फिर कोरिलेशन में भी तुम बता सकते हो कि दिस सैंड इज कोरिलेटिंग टू दिस सैंड. तो फिर जो नेक्स्ट वेल ड्रिल होगा तुम उसमें ऑटोमेटिकली वो लेयर फाइंड कर लो. So if you're putting input data, if you're feeding the algorithm correctly, it can help a lot. It can help you find probable zones of oil and gas, possible zones of oil and gas. It can help you automate the things, automate well log correlation. You can do a lot of things. You can using AI, you can analyze bulk of reports easily. Like अभी reports क्या है, एक एक करके पढ़ना पड़ता है हमें. Using AI, you can upload all the reports and you can generate insights from that. So that is one thing. AI is very helpful. Next question, please.
Uh, I guess that's it. And
Yeah, thank you.
thank you, sir. Thank you, sir, for such an informative and engaging session. We truly appreciate you taking the time to share your valuable knowledge and experiences with us today. It has been a wonderful learning experience for everyone present here. Before we conclude, we'd love to hear a few words from you, sir, your thoughts on our society and how you felt being a part of today's session.
Yeah, great. Srijita, did you ask me something? I was not like. Mm,
Sir, and Divyashri.
yeah.
Yeah, I said that before we conclude, we'd love to hear a few words from you, sir. Your thoughts on our society and how you felt being a part of today's session.
Oh, the session was good. Yeah, like uh, it was very interacting, and I guess like this type of platforms were not available in earlier days, like 2 to 3 years ago. So I guess this can help future aspirants. So you guys are doing a great job. I can see a question. Does it mean AI will take job of geologist? ये geologist का तो नहीं ले पाएगा कभी. बाकी का पता नहीं, because like it can easen up your job but it will not take your job. अब मट्टी को धो के माइक्रोस्कोप के अंदर डालना है and then analyze करके लिखना है, तो AI will not be able to do that at any cost. Or like it is all interpretation. Na? AI is helping. Like there is a AI that identifies fault, but it identifies very wrong faults. Okay, so human intervention is must in interpretation. Otherwise, like you are investing 30 crores, 50 crores in a single well. Na? You can't really rely on AI for those things for interpretation. Yeah, that's it.
Thank you so much once again, sir. Now, I would like to invite Prithvi Rai to share a few words and formally conclude today's session.
Thank you, Divyashri. Good evening, everyone, and thank you all for being part of today's talk show. As we conclude today's session, we can truly say it's been a rock solid experience filled with insights, curiosity, and inspiring ideas. A heartfelt thanks to our wonderful speaker, Mr. Amit Saw, sir, for that truly. Am I audible?
Now you are Prithvi, but earlier you weren't. Could you please repeat?
Okay. Being part of today's talk show. As we conclude today's session, we can truly say it's been a rock solid experience filled with insights, curiosity, and inspiring ideas. A heartfelt thanks to our wonderful speaker, Mr. Amit Shaw, sir, for that truly insightful and engaging session on the science and techniques of oil and gas exploration.
Great, yeah. Okay, guys, then see you. Bye bye.
Thank you, sir. Thank you so much.
Yeah.